It's a beautiful day in the neighborhood, a beautiful day in the neighborhood. Hi kids, it's a beautiful day out there. Have you noticed? Nice and springy. All the animals are happy, the birds are singing, the bees are buzzing, the squirrels are scurrying about. Do you know why they're so happy? Spring means sex for animals, and that's what this is all about. We're going to talk to you today about sexual reproduction. You may not have heard that before on my show, but we're going to learn all kinds of good things. I started to read you a book that I'm writing, but I didn't finish it. It's called Free Taylor. Now, Taylor is the story of a spermatid and his escape from the tubules of the male reproductive system. And we call him Taylor because Taylor, we don't know if he's a girl or a guy, because we don't know if he has an X or a Y chromosome. But Taylor doesn't get out, so we're just going to have to finish that later. Maybe one day I'll make a short documentary about that. So for now, we're just going to be stuck with these models, and we're going to see what happens with them. So if you will get your lab guides out and turn to page 65 in your lab guides, you can kind of follow along with me and see what we're going to learn about the male reproductive system. Now, first of all, the question is, what is the primary male reproductive organ, sexual organ? And everybody wants to say the penis, and that's wrong. It turns out it's the testes. The testes actually carry or have the ability to make sperm or spermatozoa, and that's what keeps us going. If we didn't have the testes, there would be no more species. So the testes are actually our primary sexual organ. Now, they were really, really important in the olden days, so much so that the word testify comes from men. They would place their hands over their testes. We do it over the Bible when we go to testify in a court of law, but they would place their hands over their testes so that they're swearing on the oath of my balls. Basically, I am going to tell you I'm telling the truth. But fortunately, we use the Bible now because people would probably lie less if we threatened them with that. Anyway, Miss Nick is going to talk to you about the internal structure of the testes, so I'm just going to go through kind of the external structure of the male reproductive tract. If we start first by looking at the testes, everybody wants to say that, let me get my little models here. Oh, wait. Gosh, I forgot. Never, ever touch someone's reproductive organs before you are not protected sexually. So I have to put on my hand condoms here because we don't want to get any sexually transmitted diseases. It's all about being safe, right? You know the only safe sex there is today, though? No sex. Actually, that's not true. If you and your partner are both virgins, you can have safe sex, and you don't need these. All right, anyway, let me get my model now that I'm gloved up. If you look at the testes, everybody thinks that these are the testes. Well, that is wrong. This right here is a little pouch. It's a sac called the scrotum, and that actually holds the testes. The testes are actually this little ball-shaped and aptly named, but it's actually more of an oval-shaped organ right here inside the scrotum, okay? These testes actually develop way up in here in the retroperitoneal cavity, and then about 2 months prior to birth, they're going to start migrating down. Now, in order to understand this migration, you have to think Times Square on New Year's Eve. What do we all go there to watch? The ball drop, okay? So, you take the ball that's back here, which would be the testes, and it's going to ride a cord called the gubernaculum, and I did not make that word up, and that brings it down into the scrotal sac. So this is the scrotum, and then within the scrotum, you're going to have this little oval-shaped organ here called the testes. One is called a testis, two are called testes. There's one on each side, so these are paired glands. And again, this is where sperm develop, and there's also production of testosterone for the male. That's the major portion of where testosterone is formed there. When you get down in here, each one of these testes is actually sitting in a separate compartment inside the scrotum, and they're divided. The compartment is divided by something known as a raphe. Now you say, what's a raphe? Well, if you look under your tongue, you've got a little divider under your tongue. That's a raphe. And the reason we separate these testes from each other is because these literally give life. And if one gets sick, we want it in a separate compartment so that that doesn't go over, and if there's a disease that can spread, to the other one. So it's kind of a way of saving one without messing up the other one. Now, as I said, the scrotum is just a pouch that holds these testes. And you think, why would we want the testes, if they're so important, hanging out exposed to the elements, so to speak? That just seems a very vulnerable place to put them. Well, it turns out that the reason we have to have them out here is because when spermatogenesis is occurring, you have to have the body temperature, or you have to have a temperature that's about 2 to 3 degrees lower than the body temperature. So you let them hang outside of the body temperature, that cools the testes down, and then they are able to develop at the right body temperature. Now, when you're talking about this body temperature, it's like, well, how do you control it? What if it's too hot or too cold? So you have actually two muscles in here that are going to help with this. You can see coming down on this model right here, you have a muscle that comes down and it almost forms a sling around the testes. So it's sitting like this, and then there's this sling-shaped muscle that comes around it like that kind of holds it in. That's known as your cremaster muscle. And when it gets cold, that cremaster muscle will relax and it will drop that, or excuse me, when it gets hot, that cremaster muscle will relax and drop that testes further away from the body in an effort to try to cool it. When it gets cold, it can pull it up closer to the body and give it more warmth from the body, and that way we can maintain the temperature. Now there's another muscle that surrounds the testes, and it's actually a thin muscle that kind of goes around the outside down here, and that's known as the dartos muscle. Now, the dartos muscle will give testes that nice little raisin look, okay? When it contracts, when you like get into a cold shower or a cold pool or whatever, that's going to contract and shrink up and make it all shriveled looking. That's a way to thicken up that skin and help maintain some of that body heat. Let's see, what else do I need to talk about here? Okay, also, if you look at the testes, and I'm going to look at this one right here, when you take it off here, I'm going to take the top of it off, so we're just looking at a cross-section of it, hopefully without destroying the whole model there. I don't know if you can zoom in on this and show that there are several little compartments in here. Each one of these compartments is made by the capsule that surrounds the testes. It has little dividers that goes in and makes little lobules in the testes. And then each lobule is going to have all these little curly tubes in it. Well, the curly tubes in there are called seminiferous tubules. And these seminiferous tubules are the actual site of spermatogenesis. That's where the sperm are produced. Each one of these tubules is about, anywhere from 3 feet long, somewhere like that. But then there's 1 to 4 tubules per compartment. So if you were to stretch out all these tubules, you're going to get something like 1/4 of a mile of tubules here. So there's lots of spermatogenesis going on, so we can produce lots of sperm. All right. Well, all of these tubules are going to come together, and they're going to converge onto one tubule right here at the posterior aspect on the superior side of each testes. Remember, these are paired. Whoops. Didn't mean to knock that off of you there, fella. I can't get it back on. Anyway, they're going to all converge into one tubule here, and that is going to form what's called the epididymis. Now, the epididymis runs along the back side. It just kind of makes a little cup shape there on the back side of each testes. And so all these tubules come together to form one tubule. Now, this epididymis is about 20 feet long if you were to stretch it out, but of course it's all curled up and wrapped around the back side of this each testis. Coming down, the purpose of the epididymis is it's a storage site for sperm. So they form in here in the testes, and then they're put in this epididymis, and they're stored there. They can stay there up to several months, but it takes about 20 days for them to travel through if they were just to, move on through. Now, when they're there, what happens is you get young, immature spermatids, is what they're called, coming from the testes, and then they go and sit in this epididymis, and they become mature, more mature. They actually gain the ability to swim. That's their whole goal. The sperm is going to swim to the egg. That's its job. So they're going to learn how to swim here in the epididymis, and then, of course, it's a storage site for them as well. The epididymis then goes down, and you can see, I don't know if it shows it better on this model or not. No. Okay. The epididymis comes down, and then at the base of the epididymis, you just have that one single tube coming out, and that starts the beginning of what's known as the vas deferens. It's also known as the ductus deferens. And the ductus deferens or vas deferens is nothing more than a conveyor tube. So you'll notice that this tube goes all the way up, and it comes up and around the bladder. So there's your bladder, so it comes up to the back side of the bladder. Now notice going up in this, with this vas deferens or ductus deferens here, you've got several blood vessels and nerves and things like that. Well, when that testes was descending early on in the development, or late towards the, right before birth, that gubernaculum, that tough cord that they just kind of rode down, that kind of opens up a spot here, and so you end up pulling with it blood vessels and nerves, and so all of that comes down and descends into this scrotal sac. So there's your vas deferens, and it goes up and then around to the back side of the bladder. And I'm going to take this off so you can actually see. So there's your bladder right there, and remember the bladder's nothing more than a storage vat for urine. And then your vas deferens is going to come up there. This model's not behaving for me. It's going to come up there and go around on the back side. Now, you've heard of people having vasectomies. Well, that's easy to figure out what the name is there if you can think about it for a minute. Ectomy is removal or cutting. So basically you just come right down here and you snip the vas deferens right here at the base of the testes, tie it off, or you can burn it off or ligate it. So basically anytime there's sperm formed in this testes, it's not going to have a way to get out because you've got to come up here, out, and then out the penis. So everything stays in here, and people say, oh, great, so what are you going to do with all these sperm that are forming in there? It doesn't make you any less of a man. You're still forming sperm. You're just not getting a way to sort of free Taylor. Taylor is stuck. If you cut that vas deferens there, Taylor stays inside, and he can never get out. He dies, and then, or she dies, we don't know what it is, but they're going to die down in there, and then you're not going to have any way for it to get out. So white blood cells will come in and phagocytose the remains there. So it's not like your testes are just going to blow up because you don't get it out. You just, eventually, you'll just start eating away just like you do anywhere else in the body. When you have inflammation or debris, your body just has natural ways to clean it up. All right, so we have the vas deferens coming up. Notice it comes in through an opening here called the inguinal canal. That whole spermatic cord here, which is made up of blood vessels, nerves, the vas deferens, opens into that inguinal canal right there, coming into the base of the peritoneal cavity. Then your vas deferens comes up, and then it comes around to the back side of the bladder. Now back here, it's going to open up into an enlarged area known as the ampulla. And then there's this other organ right here known as the seminal vesicle. Now you can tell from the name seminal, semen, vesicle. Well, the seminal vesicle actually forms about 70% of the fluid in semen. And most of this fluid that it forms is made up of the sugar fructose. Now you want to have a lot of fructose in there because what do these sperm that we're putting in this fluid have to do? They've got to swim and swim and swim. So they need lots of energy. So that main ingredient of the seminal vesicle then is going to be fructose, and that is going to provide the energy for the sperm to swim. You're also going to get some enzymes in here that are going to help coagulate the semen and make it thicker. So there's different things going on there. All right, now you've got the seminal vesicle joining up with the vas deferens, and they're going to come together, and I'm going to take this apart like this. And you see they form this little short duct right here. My glove's not tight enough there. They form this little short duct right here, which is known as the ejaculatory duct. So that's where the vas deferens and the seminal vessels come together and form that little short duct right there. This is inside the prostate gland. So you've got the bladder, and then you've got the prostate gland that it sits on top of. It's a little easier to see on this model right here. There's your bladder that I'm holding in my hand, and then you've got the prostate gland that sits right underneath it. Well, on the back side, you have these seminal vesicles, and then the vas deferens coming from each side of the testes. You know, they're coming up from both sides. So you've got the seminal vesicles, the vas deferens, and then those two join together and form this little short duct here known as the ejaculatory duct. All right, let me see if my notes, make sure I'm not forgetting to say anything here. Okay, this ejaculatory duct is now going to meet up with this big tube that's coming down from the bladder. Now, the penis and the urethra, which is this big tube that runs through, it goes from the bladder and goes all the way down through the shaft of the penis. That's called the urethra. Well, the urethra carries both semen and urine. And you're like, well, how does it know which one to carry? Well, when a man is sexually excited, you've got a circular muscle, which, remember what we call those? They're sphincter muscles. It's called the internal urethral sphincter. That's going to close off right here at the base of the bladder, and that's going to prevent urine from mixing in with semen. But basically, this tube right here that goes down can drain urine from the bladder, or it can drain the semen out, and it's not really draining it out, it's shooting it out that way, but it's the same tube that conveys both of them. And then again, it's that internal urethral sphincter that closes off to prevent mixing of both urine and semen. Now, about this little prostate gland here. It kind of looks about like the shape of a chestnut, the size of a chestnut. There's only one. Up until this point, we've had two of everything coming in. You've got, starting at each testes, you've got all these cords going up, two seminal vesicles, one on each one on each side of the bladder here. That shows right here, so you have one on each side. Well, now, when you get to the prostate, you just have one prostate gland. And then you just have one urethra going through that prostate gland. Now, you've probably heard of prostaglandins. They were originally discovered as secretions from this little prostate gland right here. And what prostaglandins do is they cause constriction of smooth muscle. And so when prostaglandins are secreted as part of the semen, they're going to cause the smooth muscle in the female reproductive tract to start contractions, and that's going to help propel the sperm closer to the egg and get everything where we need it to go. In men, when they reach the age of about 50, it's kind of like when you reach the age of 40, everybody has to get glasses. Well, in men, when you reach the age of about 50, your prostate is going to naturally start swelling. It's not any sickness or disease, it's just a natural swelling, and it's called prostatitis. And that will the swelling will start to compress this urethra right here, and that makes it difficult to empty the bladder completely, and you get the frequency of, if you've got to urinate, you've seen the commercial where the guy has to run out of the ball game or something real important. But that's caused by that prostatitis, which is just a normal inflammation of the prostate gland as you age. If you keep coming down, though, you call the urethra, when it runs through the prostate, you're going to call that the prostatic urethra. But then when it gets into the penis here, you're going to call it the penile urethra. Well, as the prostatic urethra gets lower, there's going to be some glands, and you can't really see them on that model, so let me show you on this one. Right here at the base of the prostate, see that little dark spot right there? That's called the bulbourethral gland. It's also known as the Cowper's gland. Cowper's is easier to spell, so I usually use that one. But there's one on each side of the urethra. So again, now we have paired glands here. And these glands are going to secrete a little clear, slimy fluid when the man gets sexually aroused. And what this fluid does is it's going to come down, it's going to be released out of the tip of the penis there, and it's going to lubricate the end of the penis for sexual intercourse. Now, some people say, oh, there's no way I could be pregnant because, the man did not ejaculate in me. Well, guess what? Sperm swim. And if they can swim through here, they're going to be able to swim through this sticky fluid and get out. And so if that sticky prostate or Cowper's gland secretion gets out, you could get pregnant from that. You don't actually have to have an ejaculation because those sperm can swim out and get free. So be careful what kind of playing around you're doing. All right. Basically, though, that bulbourethral gland is simply there for lubrication. It doesn't add a whole lot more to the semen that you're making here. And then finally, you've got the penis. Okay, so there's your penis right here. The penis is actually composed of 3 different shafts of erectile tissue. And you'll learn all about how erection works later on, but this erectile tissue, you got to think of it as like a sponge. If you have a dry sponge, it's kind of small and shriveled up. But when you put it in water, it's going to swell up. Well, the same thing's going to happen here with this erectile tissue, except it's filled with spaces for blood to fill up. You've got 3 basic tubes of erectile tissue, and it's kind of hard to see on these models, but if you can imagine, let me see if I have a pen here, yeah. If you imagine a monkey face, can you see this, Wes? Okay, where you've got 2 big tubes, and this is as if I just took a cross section, so if I just sliced a knife through there, ooh, that would hurt, but then looked on the end of it, this is what you'd see is 3 tubes of erectile tissue. These 2 tubes at the top are called the corpora cavernosa. That means corpora means body, and cavernosa, cavernous, so just cavernous bodies here. And then this one at the bottom is called your corpora spongiosum. And this also has the urethra running through it. So you're going to have an opening here where the urethra runs through. Now this tissue is not going to get as erect and tight here because you don't want to compress the urethra and you don't want to close this lumen of that urethra so that things can't get out. These 2 bodies, the corpora cavernosa, will get very tight and they don't have anything running through them. It's just cavernous bodies where blood can fill up in there. So I want you to learn which is which. When you're looking on the models, the one on top here, that would be one corpora cavernosum, and then the one on the bottom would be the corpora spongiosum. And notice that the urethra runs through the corpus spongiosum. And so you would call the urethra at this point the penile urethra because it's running through the penis. So let's see what else we need to do. Also, you need to, some teachers don't make you learn this, but just in case they do, you've got 2 terms here, the crura and the bulb. The crus or crura would be plural of the penis is going to be where this proximal ends of the corpus cavernosum is going to end, and then the bulb would be the proximal end where the corpus spongiosum ends. And some of your teachers probably won't even ask you that. Also, you're going to get an external urethral opening, so you can see here where the urethra comes out and opens up. We call that the external urethra opening, and that's where the sperm, the semen, and the urine are going to exit from. Now, if you look at the penis, you've got a thing listed here called the prepuce of the penis. That's also known as the foreskin. This particular penis, the end of it is known as the glans, so that darker area there is known as the glans. And the glans is usually covered by skin, which kind of hangs down over it, called the foreskin. And when you do a circumcision, basically you've got that foreskin, if that's the glans of my penis, it's just kind of hanging down over there, and you clip that off so it exposes the glans. And there's cultural, religious reasons why you do or don't do a circumcision. All I can say is that when I worked in the hospital and when you see men in their 40s and 50s coming in to get a circumcision, I say do it when they're young so they don't have to go through that agony when they're old. When you're talking about the penis, I like to remember Big Brown. Now that does not describe the size of the penis, nor does it describe the color. But what does Big Brown do? That's the UPS man. He makes deliveries. That's all this is. You're not adding anything to any of the secretions. You're just delivering things. So the penis is nothing more than a delivery tube. I think that about covers everything that we have to go over today. I'm really kind of tired, but y'all will just bear with me for a minute here. I don't normally smoke, but some occasions just call for it. It's really been delightful spending this time with you this afternoon, and I'm going to be talking about the female reproductive tract later on, and I hope you'll join me. Bye.